So my goal today is to get through all of the notes. So what's going to happen, we're going to take some notes. We're going to take a break and do a few problems. And then we're going to take some more notes. So we'll go to the end of the bell with notes, but the assignment that I'm going to give you for tonight, you don't necessarily, like we're going to more do it in class tomorrow. Okay, I might have you do like one problem at home. So there's going to be 2 videos. Because I can't like pause and then restart the video. But anyway, we're going to talk about something called mathematical induction. So first, this is our last day of official notes of the semester, of the decade. Okay, in a few days, it's a new decade even. Okay, so all right. Okay, and I'd say that we're on our last book assignments, but the review does involve some problems from your book for the final. Okay, so I won't say that. But we're going to talk about something called mathematical induction. Okay? In math, and those of you who go on to study pure mathematics, it's not always just about the numbers. It's about proving something is true. Okay? And so those of you who major in math, not engineering. Engineering is all computation. But those of you who go on to major in math, theoretical math is proving things that are true with numbers. Okay. So we're going to get a little taste of a proof strategy that is used. Okay, it's very straightforward compared to some of the other strategies. Oh, I didn't get mine. I forgot my mouse. Okay, and you don't need to write this down, but the reason why we're working on this in this chapter, because it feels a little bit random, is because mathematical induction, the type of proof strategy we're doing, is based on a sequence. Okay, and we just got done talking about sequences and series, and so we're going to kind of use that momentum to talk about this strategy. Okay, so mathematical induction, I want you to write down these steps. Okay. We're going to write it down, and it's not going to make sense right now. I'm going to go through an analogy, all right? And then it'll really come together here in about 20 minutes, but just be patient with me, okay? For right now, I'm just going to have you write some things down before we talk about it. So the first thing I want you to write down, let P sub n be a statement involving the positive integer n. So I'm going to give you some sort of statement. And basically what it's going to be, it's going to be the sum of a sequence equals a shortcut. I'm going to give you some sequence summed up, and it's going to equal a shortcut. And what our 2 big steps are going to be, first of all, we need to prove that when we plug in 1, it is true. All right. And then once we prove that the first statement is true, then we're going to change to k's. So everything's going to be in n's, then we're going to change to k's. And we need to show that P sub k makes P sub k plus 1 true. And if we can do that, then we can say that our formula is true for all positive integers. So write it down and then I'll talk. Okay. Okay, so we're going to show 1 is true. We're going to take our n's and make them k's. And when we make our n's k's, we're basically saying like, hey, let's pick a random number but not call it a number. We're just going to call it k. All right, we're not going to put a value on it. So let's pick a random spot in our sequence. And if we can show that the k formula makes k plus 1 true, then we can say, go back to n's and say, okay, for all integers, we're going to be okay. Or all positive integers, we're going to work. Okay? So I want to give you a little bit of an analogy here. Okay? How many of you have ever set up dominoes like this and then they all fall down? You've done that before? Okay. Whether you've done it before or not, I'm sure you've at least seen it in some sort of, whether it's live or in a video or on TV. So I want you to kind of think about these dominoes. So if I can prove the first one is true, and then in our strategy we take k and we make sure it implies k plus 1. So if I knock over the first domino, and if I can say in general, the k domino is going to knock over the k plus 1 domino, then what happens is that means the first one will knock over the second, and the second will knock over the third, and the third will knock over the fourth, and the fourth will knock over the fifth, etc., etc., etc. Okay? Until all the dominoes are knocked over. And in our case, we have an infinite number of dominoes. Okay? So if we can show that 1 is true, and if we can show that k implies k plus 1, then that means 1 makes 2 true, and 2 makes 3 true, and 3 makes 4 true, and 4 makes 5 true, on and on and on and on and on. So that's the logic behind this strategy. Okay? What I want to do before we really get into our proofs, I want to practice looking at the k versus the k plus 1. Okay? So go ahead and write this down. P sub k equals 6 over k times k plus 3. And when we get to these strategies, this is going to only be half of our statement, but I want to just kind of piece things together little by little. If we're going to write P sub k plus 1, then we are literally taking each k and replacing it with k plus 1. So when I take this k and I replace it with k plus 1, we get k plus 1. And if I take this k and replace it with k plus 1, what does that factor become? K plus 4. Right, stop right there. Okay. We're just just going to practice going from the k to the k plus 1. So this k turned to k plus 1, and this k turned to k plus 1. So you have k plus 1 plus 3. K plus 4. Are you okay with that? All right. Go ahead and write this one down. This is what's going to be on like the other side of the equal sign. And we're going to have a shortcut, so it's going to look more like it's not an equation, but we're going to have a sum equals a shortcut. So this is an example of what we would have as a sum. So if we are going to find the k plus 1 sum, any k gets changed to k plus 1. So 2 plus 5 plus 8. They don't involve a k, so they get to stay. But then we have this k minus 1. If k becomes k plus 1, what will that become? If I put a k plus 1 in for k, we have 3 times k. That's a minus 1. Okay. And then here, we're going to change this k to a k plus 1. So what we have is 2 plus 5 plus 8 plus 3k minus 1 plus 3k how am I getting plus 2? Yes. Okay. All right, one more, and then I'm going to send you to 4 problems in your homework, I think is all it is. Here is p sub k. Let's write p sub k plus 1. And that would be minus 1. All right. Go.
What's the other either I wrote it down wrong, but what is the
So every new problem, we're going to get a different piece of k.
okay.
Does that make sense?
Yeah, I just thought that was like
Nope, not permanent. Everyone will be different. Okay? So this is just like example number 3, if you will. Okay? All right, so k squared. What is it going to turn to? K plus 1 squared. K plus 1 squared will then turn to k plus 1 squared. And yes, please write it as k plus 1. Okay? Over 4. I don't want you to do anything else with it. I want it to be in the same format as p sub k. So if you have, like if this is not multiplied out, I don't want this multiplied out. See what I'm saying there? Okay. You have 6 homework problems that I'm going to give you 5 minutes to complete. And then we're going to keep going. I doubt it'll even take you 5 minutes. Okay, but we'll give some time to like compare answers and whatnot. You have 6 homework problems. Page 462. 5, 6, 7, 8, 9, and 10. Yeah.
67.
What?
You wrote 67.
Better? Okay. You have 5 minutes.